Hey scholars, welcome to another video. This week we are going to start to discuss how to represent equations using a couple of different diagrams. For today, we are going to talk about tape diagrams. Now, tape diagrams literally is exactly what it sounds like, right? They're diagrams that look like strips of tape, and if you don't remember, hang on just a sec. Here we go. So our tape diagrams are always going to look a little something like this. On the bottom here, I have the number 24. Pause and on your paper, write 3 things that you notice from your tape diagram. Welcome back. So as I was saying, we have this number right over here, 24. That is going to represent the total in our tape diagram, right? If I'm thinking about forming an equation, this whole equation is going to be equal to 24. So all of the pieces, right, all of the strips of tape in my diagram have to add up to 24. Now I have A2, A2, A2. So right over here, we notice that there are 3 groups of A plus 2 in our tape diagram. So if you notice, I have 3 A's and 3 2's. Right? So if I were to go form an equation, what do you think it's going to look like? Yeah, our equation might look a little something like this. I have 24, which is my total, and then I have 3 groups of A plus 2. Now I can also distribute that A inside of my parentheses. If I do distribute, what is my equation going to look like now? After distributing, I'm going to have 3A plus 6. 3 times A is 3A, and 2 times 3 is 6. You're good to go. So now we're going to start talking about our friend Tyler. Tyler has this huge fair going on, right? And he was designated to make all the invitations for everyone who's invited. It seems like a big task, but I think he can handle it. So shout out to Tyler because he already made some of the invitations for the fair, but he still has some left over. And what he wants to do is finish the rest of them within a week. So he's trying to spread out the remaining number of invitations, but wants to make sure that he gets the same number of invitations each day. So he's going to draw a diagram that looks something like this. So here we have our friend Tyler's tape diagram. Pause the video and write 2 things that you noticed from Tyler's tape diagram. Awesome work, y'all. So now together, let's go through each part of the diagram and try to identify what it really all means. So one of the questions that we're being asked is how many total invitations is Tyler trying to make? What do we think? Let's take a look at our diagram. Yeah, if you noted and saw that there was 122 right at the top, then you are right on track. So 122 is going to be the total number of invitations, right? We know that he has to make 122 at the end of the week so that everyone gets one and makes sure to come to the fair. So now I have this chunk over here that says 66. What do we think that represents? So if we refer back to the problem, it says that Tyler already has some invitations done. 66 is that portion of invitations that he's already made. And now the only thing left to identify is that X. What does each X signify? So X is actually going to represent the number of invites that Tyler has to make every day. Remember, if we look back at a problem, it says that Tyler wants to make the same number of invites each day. So if we take a look at our tape diagram, how many days does he have to make each invite? Let's count up the X's. 1, 2, 3, 4, 5, 6, 7. So in 7 days, he has to make the remaining number of invitations in order to make sure that he gets all of them done. So now, using what we've gathered from our tape diagram, how many invitations does Tyler have to make each day? Pause the video and try it out on your own. So one of the very first things that I can do is make an equation and then solve for X. X is what we're looking for. How many invites does Tyler want to make each day? I know that my total is 122, so I'm going to go ahead and write that here. 122 is... What is it equal to? What is our tape diagram telling us? Well, 66 plus how many X's? Yeah, you got it, 7X. I just cleaned it up for us, but it's the same equation that we just made. From here, I think we got it. We know how to solve. So on your own, pause the video and solve for x. First steps first, I want to isolate that variable, get that x all by itself. So what's one thing that I can cancel out? Yeah, it's going to be that 66. I have to subtract both sides of my equation by 66. Remember, we want to keep our equation or our hanger balanced. So 66 minus 66 is 0. If I take 66 from that side, I also have to take 66 from the other side. And 122 minus 66 is 56 is equal to what I have left, 7x. How can I get x by itself? How can I isolate that variable? Well, I can divide both. How can I isolate that variable? Well, what I did here was I divided both sides by 7. 56 divided by 7 gives me what? 8. 8 is equal to x. So when asked the question, how many invites does Tyler have to make each day in order to meet his goal? What's our answer? Yeah, awesome, 8. Now there are a couple of ways that I can check my work. Let's start by focusing on our tape diagram. I know that x is equal to 8, we just solved that. So why don't I plug in 8 for every x? That would mean that 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8, I think, plus 66 should all come out to 122. And the other way that we could do this is because we made an equation, we can go ahead and do 7 times 8 plus 66. And that should also equal the total of 122. Awesome work, scholars. Now, before we go, I want to discuss one more type of tape diagram with you real quick. Now, in this example, we have Tyler's friend Noah, and Noah and his sister are making prize bags for a game at the fair, right? So you play a game and you can win a bag. And so Noah's going to put 7 pencil erasers in each bag, and his sister is going to put some stickers, but we don't know how many yet. After filling up 3 bags, they've used a total of 57 items. So that's where we get that 57 from. Remember, the 7 is the number of erasers, and then X is the number of stickers that his sister's putting in the bag. So from here, Noah's going to try to form his own equation, and this is the equation that he writes. Do y'all agree with Noah's equation? Why or why not? Yeah, his equation is going to be right. He says that there are 3 groups of x plus 7, which is exactly the case, right? I have x plus 7, x plus 7, x plus 7, and the total is going to be 57. Now, using this equation, solve for how many stickers Noah's sister is putting in the bag. So there are 2 ways that we can go about doing this. We can start with dividing both sides by 3. Now 57 divided by 3 is equal to 19, and I'm left with x plus 7. From here, I want to subtract both sides by 7, and I'm left with x is. Now there are a couple of ways that we can go about doing this, and one of the ways that we can do this is to divide both sides of my equation by 3, right? So 57 divided by 3 is 19, and then here I'm left with x plus 7. Subtract 7 from both sides, and x is equal to 12. Now, if you'd like, you can distribute that 3 inside of the parentheses. So that's going to look like 3x plus 21 is equal to 57. From here, subtract 21 from both sides, and then whatever 57 minus 21 is, divide by 3. Now, if our calculations are correct, then your answer should also come out to x equals 12. Now, tape diagrams are really useful for us to be able to break apart the problem, especially if we're having trouble solving right at the beginning. I know you've got this. Hopefully you get some practice done